Hello to all, welcome to the channel Money's Gate Tech Vision. In this lecture, I am going to solve GATE 2022 problems in the discipline of Electronics and Communication from the subject Network Analysis. The topic which I have taken is common for electrical, electronics and instrumentation. So all the students can view the lecture series. Let me solve one by one. Problem number 1. This is the problem. The current I in the circuit shown is dash. So here one circuit given which consists of two sources. One is voltage source, other one is current source. And it consists of three equal resistance which are in equal values 2 kilo ohms. We need to find out the current I which is flowing through 2 kilo ohms. There are four options given. Okay. By observing the circuit, either we can use network theorems method or we can use network solution method because it consists of multiple sources. One is voltage source, other one is current source. So in this lecture, I have solved by two methods itself. First, I am using network theorems. So network theorems means we are having 5 theorems. So which theorems we can opt for this circuit? One is voltage source, other one is current source. So we can opt for superposition theorem. It will be easier to find the response current. What is superposition theorem? By using superposition theorem, we can find out the response by adding the responses due to individual sources acting alone in the circuit. Total response equal sum of individual responses. Individual responses is nothing but it is a response due to individual sources acting in the circuit. Now I am going to use the superposition theorem. So here two sources are there, voltage source and current source. So first I am going to activate only the voltage source. So other sources should be replaced by its internal impedance. So here it is a current source. So if the current source is replaced by its internal impedance means it should be open circuited. So current source 1 milliamps is open circuited. 10 power minus 3 amps is nothing but 1 milliamps. So 1 milliamps is open circuited. When we open circuit the current source, the circuit will become like this. This is the open circuit condition of the current source. So when we open circuit this current source, the current passing through this loop will be equal to 0 only. That we know. Okay. So here current equal to 0. I equals 0. Current flowing through this loop will be equal to 0. So directly we can discard this loop itself. So if we discard this loop itself means then what is the circuit having only 5 volt in series with 2 kilo ohms resistances. So here I1 is the current. I1 is the current due to 5 volt acting alone in the circuit. Now we are going to find I1. So I1 equals by Ohm's law V by R. V by R equivalent. Here V is 5 volt and R equivalent is 2 kilo ohms and another 2 kilo ohms are in series condition. 2 plus 2 is 4 kilo ohms. So current I1 equals 5 by 4 milliamps. Okay. 5 by 4 milliamps because it is in kilo ohms. So 5 by 4 milliamps. We have found out I1 which is the current due to 5 volt acting alone in the circuit. Now I am going to activate only the current source. Other source, voltage source should be replaced by its internal impedance. If voltage source is replaced by its internal impedance means it should be short circuited. Okay. Now voltage source 5 volt is short circuited. After short circuiting the voltage source, the circuit will become like this. So this is the short circuit condition of voltage source and only we are having only one source, current source 1 milliamps. So see the circuit, we have to find out the current I2. I2 is the current due to 1 milliamps acting alone in the circuit. Okay. Now we are going to find I2. So I2 is the branch current. Total current is given. So branch current, so we need to find the branch current. Total current is given. So how we can find the branch current? We can use current division method. We can go for current division method. So what is the current division rule? Branch current equals total current. Branch current equals total current into opposite resistance by total resistance. So here I2 equals 1 milliamps into 2 by 4. 1 milliamps is the total current and 2 kilo ohms is the opposite resistance and 4 kilo ohms is the 2 plus 2. 4 kilo ohms is the total resistance. So By simplifying, 2 by 4 equals 1 by 2 milliamps. See the direction. This I2 is in this direction, and here current will be in this direction. So opposite direction. So we can represent the current as minus 1 by 2 milliamps. So we have found out I2 and we have found out I1. Current due to 5 volt and current due to 1 milliamps. Now, by superposition theorem, total response equals sum of the responses. I equals I1 plus I2. We are going to add 5 by 4 and minus 1 by 2. So, 5 by 4 minus 1 by 2 equals, so by taking LCM, this will become 4. So, I equal to 3 by 4 milliamps. So we have found out the total response of the circuit. So total response I equals 3 by 4 milliamps. So 3 by 4 now is nothing but 0.75. 0.75 into 10 power minus 3 amps. So option B is the correct one. I equals 0.75 into 10 power minus 3 amps. So by using superposition theorem, we have found out the response current in the circuit. For the same problem, I am going to solve by using network solution methods. Okay. So which network solution methods? We can take the loop itself. We can take the loop itself. So here I am assuming the current for the first loop is I1 and for the second loop is I2. Okay. First loop current is I1 and second loop current is I2. So I am going to write the equation for loop 1 and loop 2. So for the loop 1, see the loop 1, it consists of voltage source and 2 kilo ohms. Another 2 kilo ohms is there. So I am going to use Kirchhoff's voltage law. By using Kirchhoff's voltage law, what is Kirchhoff's voltage law? Sum of voltage drop equal to sum of voltage rise. Okay. Sum of voltage drop equal to sum of voltage rise. So before that, I am assuming I equal to I1. Okay. So for loop 1, 5 volt is the voltage rise and voltage drop is 2 plus 2, 4I1 minus 2I2 equals 5. So I have written the equation for loop 1 by using Kirchhoff's voltage law. See the loop 2. So loop 2 consists of only current value. Okay. So current value means here I2 is the assumed direction and here given direction is in anti-clockwise direction and assumed direction is in clockwise direction. So we can write directly in loop 2 I2 equals minus 10 power minus 3 amps or minus 1 milliamps. Okay. So we are having I2 value in the loop 2 itself. So now substituting I2 in the loop 1 equation. We can substitute the I2 value in the loop 1 equation and we can find out I1. Substituting I2 equal to minus 1 milliamps. 4I1 minus 2 into minus 1 equals 5. So it will become positive and 5 minus 2, that will become 3. So 4I1 equal to 3. Again I1 equal to 3 by 4 milliamps. So I1 we have assumed as I. Okay. So we have assumed as I. So I equal to 3 by 4 milliamps. So we found 3 by 4 milliamps. 3 by 4 is nothing but 0.75 into 10 power minus 3 amps. So option B is the correct one. Either we can use network theorems method or we can use network solutions method. Next problem. Consider the circuit shown in the figure. The current I flowing through the 10 ohms resistor is. So this is the current flowing through 10 ohms resistance. See, observe the circuit neatly. So here this is opened, this 10 ohms is not grounded, this branch is not grounded. So directly we can tell the current passing through this is 0 because there is no ground condition. See here, if we are having the circuit like this, means if there is a closed path means we can find out the current. But here in the question it is not given like this. It is not given like this. This is an open path. There is resistance is not grounded. So if we are having no written path, there will be no current. So here I will be equal to 0 only. I will be equal to 0 only. By observing the circuit itself, we can find out the current. So I equal to 0 amps. Option B is the correct one. B is the correct one. Since the resistance 10 ohms is not grounded, no current flow through the resistance, hence I equal to 0. So option B is the correct one. Or we can use source transformation method. By using source transformation method, voltage source can be converted into current source and current source can be converted into voltage source. So here 3 volt in series with 1 ohms and here also 3 volt in series with 2 ohms. Okay, by using Ohm's law, we can find out the current value by V by R, 3 by 1 and here 3 by 2. By using source transformation method, first I am going to transform the voltage source into current source and here 3 amps and here 3 by 2 amps in parallel with the resistance. Here also in parallel with the resistance. Again equalizing this parallel condition in either side, 1 ohms parallel with 2 ohms and 1 ohms parallel with 2 ohms. So here, see here. So this is 1 ohms parallel with 2 ohms and here 1 ohms parallel with 2 ohms. So after rearranging, the circuit will become like this, 2 by 3 ohms, 2 by 3 ohms. I is the current flowing through 10 ohms. So again current source in parallel with resistance and here also current source in parallel with resistance. Again transforming this current source into voltage source. This will become 2 volt in series with 2 by 3 ohms and 1 volt in series with 2 by 3 ohms. So again we are having no return path. There is no return path. This is an open path. This is not a closed path. So here also I equal to 0. So we can find I equal to 0. Directly we can by observing the circuit itself, we can find the current equal to 0. If we use source transformation method also, finally the answer will be equal to, answer of the current will be equal to 0 amps only. So option B is the correct one. I equal to 0 amps. This is Mani's Gate Tech Vision. This is a channel for engineering competitive examination. You can subscribe to my channel, share the video lectures, view the video lectures regularly. It will be helpful for your competitive examinations. Thank you very much. This is my mail ID, dmoneylecture@gmail.com. You can mail to me. You can clear your doubts also. Thank you very much.